Hello viewers, I have already discussed the heart of the geometric shape in my previous video, that is triangle and their properties. Now in this video I am going to discuss about the quadrilaterals and their properties. What are quadrilaterals? Quadrilaterals are polygons which have four sides, four vertex, and four angles. Here, here A, B, C, D is a polygon which has four vertices. A, B, C, and D are the four vertices. And A, B, B, C, C, D, and D, A are the four sides. And angle A, angle B, angle C, angle D are the four angles. The sum of interior angles is 360-degree and sum of exterior angles for quadrilateral is also 360-degree. These are same. Interior sum of interior angles equals to sum of exterior angles equals to 360-degree for a quadrilateral, and there are two diagonals. AC and BD are the two diagonals of quadrilateral ABCD. Quadrilaterals are of different types. They may be classified into trapezium, parallelogram, rectangles, square, rhombus, kite. Now, one by one, I am discussing the different types of quadrilaterals. First of all, I am going to discuss about the trapezium. When two sides of a quadrilateral are parallel to each other, then it is known as trapezium. Here, in this quadrilateral ABCD, the two sides AD parallel to BC. So, it is a trapezium, right? One pair of opposite sides is parallel. Here, AD parallel BC, and these are known as parallel sides of the trapezium. The other two sides, AB and DC, are known as legs, are the legs of this trapezium ABCD. Similarly, the name of this two angle, that is angle BAD and angle CDA, is base angles. Base angles. Angle A and angle D are the base angles. So the angles with the shorter side of parallel side are known as base angles. AD and BC are the bases. The parallel two sides are known as bases. So once again, in trapezium ABCD, AD parallel BC and side AD and BC are known as base, and side AB and DC are known as legs, and angle A and angle D are known as base angles. Now, in this trapezium, BD and BD and AC are the diagonals. Okay, written here. BD and AC are two diagonals of this trapezium ABCD. And already I told that the interior angle, the sum of interior angles of a quadrilateral is equals to 360 degree. Since ABCD, trapezium ABCD is basically a quadrilateral, therefore the interior angles ABCD, sum of these interior angles is equals to 360 degree. Okay. Now let us take the midpoint of AB as E and the midpoint of DC as F. Then EF will be equals to half of AD plus BC. AD and BC are the parallel sides of this trapezium, and EF is the median of this trapezium ABCD, and EF parallel to AD and parallel to BC. EF parallel to AD and parallel to BC. How this relation we get? I am showing that. Just draw a diagonal BD. You may add AC also, but I am joining B and D and get the diagonal BD. Then I got two triangles, triangle ABD and triangle BCD. And since E is the midpoint of AB and EF parallel to AD, since E is the midpoint of AB and EF parallel to AD, therefore we can say that this point let this point be G. Say that EG equals to, sorry, EG equals to half of AD. Okay. Similarly, for triangle, this is for triangle ABD, and for triangle BCD, F is the midpoint of DC and BC parallel to EF. Therefore, FG equals to half of BC. This is equation number 1 and this is equation number 2. If we add these two equations, then we will get EG plus FG equals to half of AD plus half of BC, or EG plus FG, what we get? EF. So EF equals to half, taking common from these two terms, then we will get half into AD plus BC. And again, we know that AD plus BC here are the parallel sides of the trapezium. So the relation is proved. EF equals to half into AD plus BC. Okay. Next, what is the height of this trapezium? We have to know what is the height of this trapezium. If we draw a perpendicular from vertex A to the base BC, then the distance will be height. Similarly, from any point of AD to perpendicular distance of BC is the height of this trapezium. So the perpendicular distance between the parallel sides is the height of the trapezium. Understand? Perpendicular distance from in between two parallel sides of this trapezium is known as the height of this trapezium. Now we will calculate the area of a trapezium. How do we calculate? If we draw a diagonal of this trapezium AC, then AC split this trapezium into two triangles. One is triangle ABC and another is triangle ADC. Now we know that area of a triangle is equals to half into base into height. So triangle ABC equals to half of base BC into height H. Similarly, triangle ADC area of triangle ADC equals to half of AD into H. AD into H. Okay. For ADC, triangle ADC, the H will be the same of the height of trapezium. Okay. So if we add the area of triangle ABC plus triangle ADC, then we will get half into half H into BC plus AD. Therefore, the area of trapezium ABCD equals to half into B1 plus B2. B1 is the length of suppose AD and B2 is the length of BC. Then the formula comes area equals to half into H into B1 plus B2. That is the sum of the parallel sides. Okay. So once again, the formula is area of a trapezium equals to half into its height into its sum of two parallel sides. Certainly, you heard the term isosceles trapezium. What is the isosceles trapezium? We already familiar with the word isosceles, where isosceles triangles. Okay, in these triangles, two sides are equal and known as isosceles triangle. Similarly, isosceles trapezium means if the legs of the trapezium are equal, then this is known as isosceles trapezium. Legs are equal. Here, legs AB and DC are equal. AB equal to DC. And similarly, when these two sides are equal, then their corresponding base angles will be equal. Okay, so angle A equals to angle D and angle B equals to angle C. Or two diagonals AC, AC, AC and BD are also equal. So diagonals of isosceles trapezium are equal. AC and BD, AC and BD bisect each other bisect AC and BD do not bisect each other. Do not bisect each other. In this diagram, it is clear that this is not equal to this side and this part is OD is not equal to OD. OD is not equal to OB. So AC and BD do not bisect each other. One thing to be remembered, isosceles trapezium is cyclic. You know the meaning of cyclic? That is nothing but I am saying again, these are the four vertex A, B, C, D are the four vertex. We can draw a circle. We can draw a circle taking these four vertices. That is, isosceles trapezium is known as cyclic. Any quadrilateral will be cyclic if their opposite angles, here angle B and angle D and angle A and angle C are the opposite angles. When the sum of opposite angles, that is for this figure, angle B equals to plus angle D equals to 180 degree, then the quadrilateral will be cyclic. In this case, since angle B plus angle D equals to 180 degree as well as angle A and angle C equals to 180 degree, so this quadrilateral, that is isosceles trapezium, here isosceles trapezium is cyclic. Okay. Now come to the figure parallelogram. What is parallelogram? Opposite sides. If the opposite sides of a quadrilateral are parallel and equal in length, then this is known as parallelogram. That is, in this figure, ABCD, AD parallel BC and AB parallel DC, so it is known as parallelogram, right? In parallelogram, it is also proved that it may be proved that or that AD equals to BC and BC equals to AD equals to BC and AB equals to DC. That is, opposite sides are equal to each other. Opposite sides are equal to each other. So, in a parallelogram, opposite sides are parallel as well as opposite sides are equal. Sum of adjacent angle is 180 degree. These are the adjacent angle. The sum of this adjacent angle, angle B plus angle C equals to 180 degree. It may be proved easily. AB and DC are the parallel sides and DC is the transversal. Okay. So these two angles, sum of these two angles will be 180 degree. Similarly, angle A plus angle D equals to 180 degree, angle A plus angle B equals to 180 degree, and angle C plus angle D equals to 180 degree. These are all the pairs of adjacent angles. In parallelogram, the sum of adjacent angle is 180 degree. In parallelogram, opposite angles are also equal. Opposite angles are equal. Here, opposite angles, pair of opposite angles, angle B and angle D. So, angle B equals to angle D. Similarly, angle A equals to angle C. Diagonals. We know that in a quadrilateral, there are two diagonals. So, a parallelogram is basically a quadrilateral. So, there are two diagonals. Here, BD and AC are the diagonals, and they are not equal to each other. BD and AC bisect each other. They are not equal, but bisect each other. Bisect means equally divided in the intersecting point. Here, intersecting point is O. So, AO equals to CO as well as BO equals to DO. AO equals to CO and BO equals to DO. Two diagonals bisect each other at point O. Okay. A diagonal splits this parallelogram into two halves, into equal two halves. Okay, that is why triangle ABD will be congruent to triangle BCD. Similarly, diagonal AC divided this parallelogram into two equal halves, triangle ABC and triangle ADC, and these two triangles are congruent. ABC, AD, ACD, and ABD, VCD. Okay. They are congruent. Because if we take these two triangles, ABC and AD and ADC, then the corresponding sides BC equals to AD and AB equals to DC, and their angles, in between their angles, ABC equals to angle ADC. So these two triangles are congruent. Similarly, we can prove these two triangles are also congruent. Okay. If we write like that, triangle ABC and triangle ACD, BC equals to AD, BC equal to AD. Why? Since they are the they are the opposite sides of a parallelogram. And similarly, AB equals to DC, since they are the opposite sides of a parallelogram. And the angle ABC equals to angle ADC, since they are the they are the opposite opposite angles of a parallelogram. Therefore, triangle ABC congruent to triangle ACD. Understand? Now, how do we calculate the area of a parallelogram? It is very easy. If we extend the base BC and if I draw a perpendicular on it from point D, then we will get the height of this parallelogram. D is the height of this parallelogram. Now, the area of parallelogram. Let us take the diagonal BD, then diagonal BD divides this parallelogram ABCD into two triangles BCD and ABD. Triangle BCD and triangle ABD. Now the area of triangle BCD equals to half of base here BC into height H. Okay. As well as area of triangle ABD equals to half into AD into H. H is the height of these two triangle BCD and triangle ABD. Okay. So if we add these two area, then we will get area of parallelogram ABCD equals to half into H into BC plus AD. So, half plus half, need correction. Half into BC into H plus half into AD into H. So what will come? Half into H into BC plus AD equals to half into H into 2 BC, because BC equals to AD, they are the opposite sides of a parallelogram. So H into BC, that is one of the base. Okay. So the area of a parallelogram is equals to base into height. Which base? Which one is base? Now, related to the height. If we take this height, then the base will be either BC or AD. If we take the height horizontally, then the base will be AB or DC. Okay. According to the taking of height, we have to select the base. So finally, we can be told that area equals to base into, okay, area of parallelogram equals to base into height. Now we will come to the rectangle. Rectangle is also basically a parallelogram, that is basically a quadrilateral, which has opposite sides are parallel and equal, and all angles are of 90 degree. So in short, if we have any angle of a parallelogram is of 90 degree, then we may conclude that this parallelogram is a rectangle. Okay. Already I told for here ABCD, rectangle ABCD, AD equal to BC and AD parallel BC. Similarly, AB equal to DC and AB parallel to DC. So opposite sides are equal and parallel, and each of angle A equals to angle B equals to angle C equals to angle D equals to angle 90 degree or one right angle. And there are two diagonals, AC and BD are equal and intersect each other at O. They are also bisect each other. Okay. That is this equal to this equal to this. Diagonal AC bisects BD. Okay. What is the area of rectangle? Since rectangle is the basically a parallelogram, so already we know that the area of a parallelogram equals to base into height. So here the base is the length and height is the breadth. Since this is 90 degree, so breadth is the height of rectangle. So the area of rectangle is length into breadth. Okay, length into breadth. Rectangle is also a type of cyclic quadrilateral as opposite angles are supplementary. That is, supplementary, angle A plus angle C equals to 180 degree. That is, A and angle C are supplementary to each other, and angle B plus angle C are also supplementary. So, rectangle is cyclic in nature. But what you have been seen that a parallelogram is not a cyclic in nature. Already I discussed the condition of cyclic quadrilateral for it may be alternately prove that for a cyclic quadrilateral AC plus BD equals to EF, where AC and BD are the opposite sides. Let one quadrilateral quadrilateral if AC plus BD equals to EF, then we may say that this quadrilateral is of cyclic in nature. Okay. Area of a cyclic quadrilateral will be root over of S minus A into S minus B into S minus C into S minus D. What is the S? S is equal to A plus B plus C plus D divided by. If we take a rectangle simply having length equals to 5 centimeter and the breadth equals to 2 centimeter, then the area of ABCD equals to 5 into 2 equals to 10 centimeters square. If we use this formula to find out the area of this quadrilateral of this rectangle, then what will we find? Let us see. A is equal to 5 plus 2 plus 5 plus 2 divided by 2 equals to 14 by 2 equals to 7 centimeter. and the area equals to 7 into 7 minus 5 into 7 minus 2 into 7 minus 5 into 7 minus 2 equals to root over of 7. Sorry, this 7 will not come according to the formula. So it will come 2 into 5 into 2 into 5. The square root of this equals to, we know that 2 into 5 equals to 10 centimeters square. So these two are the same. So in this way, we also find out the area of any cyclic quadrilateral. The formula is area equals to S minus A into S minus B into S minus C into S minus D. Now come to the square. Square is also a quadrilateral whose all sides are equal. If a rectangle has all sides are equal, then it is known as square. Here I have drawn a square ABCD whose all sides are equal to A. That is AB equals to BC equals to CD equals to DA equals to A. And all the angles are of equal to 90 degree. 90 degree. All sides are equal, all angles are equal, and each angle equal to 90 degree. Diagonals are here diagonal AC equals to BD. There are two diagonals AC and BD. These are equal and bisect each other. That is AO equals to CO and BO equals to DO. Bisects each other at intersecting point O, right? And also here is an additional feature. Diagonals are intersected each other at a right angle. That is angle AOB equals to angle DOC equals to angle AOD equals to angle BOC equals to 90 degree. Okay. In statement, it can be stated as diagonals of a square bisect each other at right angles. Okay. A square is also cyclic because angle A plus angle C equals to 180 degree. Opposite angles are in supplementary. Angle B plus angle D equals to 180 degree. So a square is cyclic. Sum of adjacent angles are also 180 degree. Adjacent angle, you know, angle A plus angle B equals to 180 degree. Angle A plus angle D equals to 180 degree. Angle D angle plus angle C equals to 180 degree. Angle C plus angle B equals to 180 degree. Sum of opposite angles are also 180 degree. That is why square is cycle. Right. So area of square. Area of square equals to side square. That is, in this case, area of square ABCD equals to a square, since the length of the side of this square is A. Okay. So it is the formula for calculating area of a square. So what is the perimeter of a square? Perimeter equals to A, all sum of all sides, 4. Right. And what is the perimeter of a rectangle? Perimeter of rectangle ABCD equals to AB plus BC plus CD plus DA equals to 2 into length plus breadth. Okay. Perimeter is nothing but the sum total of all sides. Now we come to the rhombus. Rhombus is a square Rhombus is like a square but not a square because rhombus has no angle equals to 90 degree. Rhombus has all sides are equal but no angle is 90 degree. So it will looks like that. All sides are equal. Let be A, but no angles is equal to 90 degree. So diagonals are not equal. As the angles are not equal, so the diagonals are not equal. ABCD, diagonal AC not equal to diagonal BD, but sides are equal. Therefore, diagonal bisect each other at right angle. It is an important parameter or property of a rhombus. Diagonals bisect each other at right angle. What will be the area of a rhombus? It is very easy. Area equals to side into height. Side into height. Height here. This is the height of this rhombus. Okay. These are all heights. All are equal to h. Right. Now come to the figure kite. If two pairs of adjacent sides are equal in length, then the figure is known as kite. In this figure, ABCD is a kite because the adjacent two sides AB equals to AD and BC equals to CD. So ABCD is a kite. There are two diagonals, BD and AC. These two diagonals intersect each other at right angle. Okay. The area of kite equals to the area of two triangles formed by drawing any of the diagonal. A diagonal divides a kite into two parts, that is in two triangles. If we add the area of these two triangles, we get the area of, okay. We already come to know how do we calculate the area of triangle. Since ABD and BCD, triangle ABD and BCD are isosceles. Isosceles because their two sides are equal. So we can find more easily the area of triangle ABD and triangle BCD. Okay. And we also find a property of kite, that is triangle ABC and triangle ADC are congruent as well as similar because of their respective sides are equal and respective angles are also equal. And we get only one line, that is AC, which is symmetrical line for kite ABCD. If we fold aligned to AC, then the diagram, the half of the diagram will superimpose to the another half of this diagram. So this is AC is the symmetrical line. Thank you very much. Thank you to all to see the video. It may be noted that in this regard, FinSplit will launch a short-term placement training program in which RRB, SSC, and other competitive examinations aspirants will be benefited to take this course. Thank you, all of you, again. And I am ending this video here. Thank you.